All right, now our third wing has another set of doors. Okay, so it has the door at the end and then two sets. That's when L equals 2. Okay, everything else is just the same. The numbering 0, 1, 2, -1, and -2. Okay, now you'll notice the shape for the D orbital. Yes, we also give this the letter D. It has 4 lobes. Okay, so it's kind of like you took this P orbital and pinched it through the top and bottom, giving both of those a pinch, and then you have 4 lobes. Okay, and there are 5 different possible orientations for that, and it's too much to try and draw that. There are pictures of that, and that part isn't too important. The important part is just to remember there are 5 different orientations for those orbitals, and in each orbital there are 2 electrons. Okay, in each room there are 2 seats for those electrons. Okay, so the D orbital, the D subshell, rather, the D wing, it has 5 orbitals and a total of 10 electrons in the D wing. 2, 4, 6, 8, 10. Okay, so that is the third level. Okay, so all of the, breaking this down into the hierarchy. Okay, in the atom, the level, that's like the shell. Okay, all of these electrons here, all of those chairs that I've drawn out, those are all in the n equals 3 shell. Okay, now within that shell there are 3 subshells. Okay, there's the P, the S, the P, and the D subshell. And then within the subshell there are the orbitals. There's 1 s orbital, there's 3 p orbitals, there are 5 d orbitals. Okay, and within each orbital there's a maximum of 2 electrons. Okay, so now let's go up to the next level, and this is the last one that I will draw out. Okay, now bear in mind the angles and stuff here, that's irrelevant. The key is that we're on level 4, n equals 4. Okay, and we have 4 wings in our hotel. Okay, so the first wing, L equals 0, it's our S wing. There's 1 orbital, 2 electrons, m sub s positive negative 1/2, and m sub L is 0. All right, in our P wing, looks just like it did before. L is 1 for the P wing. M sub L can be 0, 1, or -1. Okay, we have that set of doors behind the end door. So we have a total of 3 orbitals, and I stopped drawing them for space, but there's 2 seats for each of within each of the orbitals for the 2 electrons. Okay, so there's the P subshell. Then we have the D, again, looks just like in the lower level, where we have m sub L, 0, 1, -1, 2, and -2. Okay, so we have 2 sets of doors on either side of the hallway, total of 5 orbitals, and each orbital contains, like I've drawn up here, 2 electrons, m sub s, -1/2, positive 1/2. That's the case for each room. All right, so this is the D subshell with its 5 orbitals. Each one has 4 lobes, and it contains 2 electrons. And there are 5 different possible orientations for the d orbitals, 3 possible orientations for the p, only 1 orientation for the spherical s orbital. Okay. Now the third L equals 3, the last wing in this level, we call it the F subshell, the F wing. All right. It has a third set of doors. So we have 0, positive, negative 1/2, positive and negative 1, positive and negative 2, positive and negative 3. Okay, those are the values for M sub L. And you'll notice there's a total of 7. Okay, now the shape for the F orbitals, I'm not going to try and draw it, but again, just like before, we took the spherical orbital, we pinched it, and we got this kind of a pinched shape. Then we took that and we pinched it again, and it has 4 lobes. Okay, so you can think of it, if you kind of took that and pinched it in the plane of the paper, where each lobe is cut in half, you're going to end up with a shape that has 8 lobes. Okay, kind of like all pointing to the corners of a cube. You might think of it like that. And there are 7 possible orientations for that 8-lobed shape, those orbitals. All right, 7 different orbitals within the F subshell, and that gives rise to 14 electrons, because behind each door there are 2 chairs for the 2 electrons. Right, so 7 orbitals within the F subshell. Okay, the F wing of the hotel. All right, and of course the whole level, all of the electrons in this level are the n equals 4 shell. All right, so each level is a shell. That's the n equals 4 shell. Here's the n equals 3 shell with its 3 different wings, S, P, and D. And then the n equals 2 shell with S and P. And the n equals 1 shell with just the one S wing. Okay. So shells, subshells, and orbitals. Each orbital has 2 electrons. And you'll notice there's a unique set of these 4 quantum numbers for each chair, in other words, each electron in the atom. All right, so these 2 electrons, those 2 chairs, have n equals 1, L equals 0, M sub L equals 0, and M sub S is negative 1/2 for this one, positive 1/2 for that one. Okay, and then these ones all look the same, but n equals 2. Okay, so all of the S subshell electrons, all the electrons in the S subshells, whether they're on level 1, 2, or 3, or whatever level they're on, they all have L equals 0, M sub L equals 0, M sub S is negative 1/2 and positive 1/2. The only number that's different is n. Okay, so unique values for all 4 of the quantum numbers that represent each and every electron in the atom. All right, hopefully this will help to remember these restrictions and put it maybe in more understandable or visual terms. Okay, so but just remember, N determines the energy level, L tells us about the shape, whether it's spherical or that dumbbell shape with the 2 lobes or 4 lobes or 8 lobes. And then M sub L tells us about the orientation, whether it's vertical, horizontal, or out of the plane of the paper. And then M sub S is kind of like clockwise or counterclockwise. Okay, that's why there's just 2 values, 2 different possibilities for the direction of the spin. Okay.